Hello everyone. In this video, I'm going to show you one of your homework problem. And this work problem also kind of difficult to solve. Okay, so that's why I want to demonstrate this example. Okay, it's your problem 9.79. Okay, and here's the problem description. It says there's a frisbee and it's stuck on a tree. Okay, and its height is 7.25 meter above the ground. And then you want to free this frisbee, so you throw a dirt. And this dirt, it gives you a mass. Okay, and throw a dirt and then throw it vertically upward. And it said the initial position of this dirt is 1.23 meter above the ground, and you give this dirt an initial velocity 18.7. And then after dirt hit the frisbee and then they stick together and then move together. And then this combination will keep moving up and then reach the maximum height. And then after reaching the maximum height, and then it will fall, and then it will do the free falling motion and then to the ground. And the problem asks you to find the maximum height of the frisbee dirt combination and the speed when then hit the ground. Okay, and this problem is, it's kind of combined with energy conservation or not energy conservation. Yeah, we have a little bit energy conservation and also momentum conservation and kinematics together. So it's not easy to solve. So okay, I drew the scheme for this problem. Okay, so first of all, you throw the dirt to the frisbee, and we'll assume it's very vertically. Okay, one-dimensional motion, but actually in reality it's very difficult to conduct only one-dimensional motion. Okay, but for this practice problem, just assume it's one-dimensional problem. Okay, and one-dimensional problem. Okay, you hit the frisbee and then move together. So actually this will be an inelastic collision. Okay, because they move together after collision, they move together just like ballistic pendulum we introduced in a lecture. Okay, after the inelastic collision, you have a carrier velocity and move together to the maximum height, and at the maximum height it will have the zero velocity, right? Reach the maximum height, it will have the velocity will become zero. I think velocity will become zero. And here we call it maximum height. Okay, here we call it maximum height. I think I should use the pen ruler for this. This is called maximum height. This is called maximum height. This is h. This is called h maximum. Okay, but from this graph, we already know like this part is 7.25. Not exactly here. This part is 7.25. So all we have to calculate is this part. Okay, it's this part. Let's call it delta y. All we have to do is this part. Okay, so you want to calculate distance of this part. Remember using the kinematics equation. Okay, if you want to calculate the distance for this part, and then using the kinematics equation, you need the velocity at the initial position and the final position, right? Okay, because position here is zero, we already know that, but we don't know the position. We don't know velocity right after the inelastic collision. So we have to figure out what's the velocity right after the inelastic collision. Okay, because without this information, we cannot calculate the distance delta y here. So how to calculate the velocity right after the inelastic collision? We have to consider the velocity just right before the inelastic collision. Okay, so initially you throw a dirt vertically upward and 18.7 initial velocity. So just right before the inelastic collision. What is the velocity? Okay, just right before the inelastic collision, what is the velocity here? Right, just right before the inelastic collision. It's 18.7. No, not 18.7 anymore, because we have the gravitation, acceleration of gravitation, g equal to 9.8 meter per second square acceleration, and it's pointing downward. So at this position, right before the inelastic collision, the velocity of the dirt is no longer 18.7 anymore. So you have to calculate the velocity just right before the inelastic collision, and then get the velocity right after the inelastic collision, and then get a distance here. And then when the combination reach the maximum, and then it will do the free falling motion, and it will hit the ground. We call it V final, and final V final. Okay. Okay, but before that, before calculate V final, you have to calculate the maximum height. Okay, so lots of connection here. So this problem is not easy to solve. Okay, so let's just start to solve this problem. Okay, we start from how to solve what's the velocity just right before the inelastic collision. Okay, let's start with V equal to Vf equal to Vi plus At, right? Vi is 18.7, and acceleration is 9.8 point down. So be careful. There's a minus sign here. And t. Okay. We want to calculate the velocity here. So Vf just equals to V. So V equal to 18.7. Yeah, 18 point minus 9.8 t, and t we don't know, so we have to figure out what is the t. So we have another equation. Okay, yf equal to yi plus vi times t plus 1 over 2 at squared. So the final position here, just right before the inelastic collision, its height is 7.25. And initial height is 1.23 above the ground, and initial velocity is 18.7 t. And here, acceleration is minus 9.8. 9.8 here, and it's minus 9, so times 1 over 2, so it's minus 4.9 t squared. And then you do some arrangement, you will reach this equation like this, for quadratic equation like this, minus 18.7 t, and the plus, what's the plus 1602 equal to 0. You got a quadratic equation. And then this quadratic equation, you got the two answers. I think one is, okay, just calculate by yourself. I just give you the answer quickly. One is, one is 0.36, and the other is 18.7 plus 15.22 divided 9.8. The other is 3.46. Okay, you got two answers. Which one is reasonable? That's why we need this equation. Okay, so you put this t back into this equation. Okay, and you will find this is reasonable, because 3.46, it will become negative, and the negative means point down. So it will become point down right here, but that's the point down right here. That doesn't look reasonable. Okay, so this 0.36 is reasonable. So our V is 18.7 minus 9.8 times 0.36. So what's our velocity? 18.7 minus 9.8 times 0.36. So it's 15.17. So I think at this position, its V is equal to 15.17. Okay, so we have this velocity right before the inelastic collision, so we can find the velocity right after the inelastic collision. Just use the momentum conservation. So we have all the information, because our dirt, we have mass times its velocity plus the free speed, and times its velocity. And velocity is because at rest, so no velocity. equal to that, and if and then they move together after all, and then we have the velocity. Okay, this is pi minus pf, momentum conservation. Momentum conservation. So this equation is using momentum conservation. Yeah, in elastic collision, yeah, kinetic energy is not conserved, but if once the system is isolated, momentum always conserved. And that's the beauty of momentum conservation. Okay, elastic collision, but system is isolated, and the collision is the internal force, so momentum always conserved. So, okay, so momentum conservation. And we have information of mass. Yes, we have the dirt is 0.24, right? And frisbee 0.124. So if with this information, yeah, we can get a VF. Okay, what's a VF? V is just what we calculate, 15.17. Okay, so the velocity after the collision is, right after the inelastic collision is, okay, let's see. I think it's about 10. I just did the check. 15.17 and then divided by 0.24 plus 0.124. Yes, 10.00. 10.00. So right after the inelastic collision, the velocity is equal to 10.00. Okay, so if we got information after they move and then they move together to the maximum height, velocity becomes 0. So what's our distance delta y? I think you love this equation in the kinematics, but I'm not a fan of this equation. Is v2 squared equal to v1 squared minus 2 a delta x, right? So our a is 9.8. So our delta y is square 10 squared 2 times 3a is 9.8. Okay, so what is our delta y? I think 5 point something. To 9.8. Okay, it's 5.10. 5.10. Answer is meter. So this distance is 1.10. Okay. So what is our h maximum? H maximum is this distance plus this distance. So it's h max is equal to 5.1 plus 7.25, and the total is 12.35. That's our H maximum height relative to ground. So it's 12.35. And so what's the final velocity when this combination hit the ground? Actually, yeah, you can use kinematics, but also we can use energy conservation to solve the same problem. Because this free falling motion, there is no friction. Yeah, we don't assume there's not any air resistance, no friction, no external force. So system is isolated. So this system is we can use the mechanical energy conservation. So mechanical energy conservation. Do you know how to use the equation? Mechanical energy conservation. Okay, I just do the calculation here. Mechanical energy conservation is delta K plus delta U is equal to 0. And in this system, we don't have any spring, so we only have to consider the gravitational potential energy. We don't need to consider elastic potential energy. So after this combination hit the ground, we assume the velocity is v final. Okay, so 1/2, and be careful. Right now we have frisbee plus the dirt is our mass, and v final square. We don't know that's what we are going after. So initially it would velocity free falling from velocity equal to 0. So its kinetic energy is 0. So this is 0. So we don't need to take care. We don't have to write this down. And the final position of the gravitational potential energy, I can set the height origin here is 0. Okay, so the potential energy, the ground is 0. So it's 0. And minus initial potential energy. And initial potential energy, that's why we have to calculate the height. height maximum is 12.35. And don't forget our mass right now is combination NF plus MD, and the times MGH is the potential energy. So times 12.35 and then equal to 0. So we will get the equation like this. 1 over 2 NF plus MD V final square equal to MF plus MD dirt and G and times 12.35. I don't have any space here. Maybe I should move to the left, more on left. Okay. Okay, so okay, this is times 12.35. Okay, so on both sides we have the mass. Okay, we have the same mass. So Q it. So our final velocity is Vf is equal to square root of 2 times G is 9.8 times 12.35. And what's our final answer? So velocity will hit the ground 2 times 9.8 times 12.35. Take square root. It's about 15.56. 15.56 in the meter per second. That's my answer. Okay, that's what the problem asking for. Velocity when the combination in the ground and the H maximum. Okay, that's the answer. So this is a combination to the kinematics, momentum conservation, and energy conservation. So it's also not an easy problem. Take a while to solve that. Okay, so I just stop video here. Hope this will help you your homework. Okay, thank you. I'll see you in another video. Bye bye.